Hello everyone, welcome to Abhijeet Codes. So in this video, we're going to see how to insert a node at the end of a linked list. So we'll be given the head of the linked list and some data variable. Okay. So this will be the value of the new node which we need to insert at the end. So if you haven't watched the previous videos, I would suggest please go and watch them because the series is made to watch the videos in a continuity. Okay. So how can we add a node at the end of a linked list? So we have seen that when we had to add a node at the beginning, we simply created a node and we pointed its next to the head, and then we moved the head over here. So this was very simple because we had the access of head. Okay, head access we have given, but now we don't have the access to tail. So in the previous video we have seen how to traverse a linked list. Okay, so we will start traversing. So what we'll do, we'll make a current and it will in the beginning point to head. So our current will point to head of the linked list. Okay, then we will move our current by one step. So we'll move current will come here, it will come here, it will come here, it will come here, it will come here, but we have to stop here only, we don't need to go here. So we need to stop at the node whose next is null. Okay, so if we found a node whose next is null, we need to stop. So what we'll do, we'll run a while loop while current's next, that means a node whose next is equal to null. So we have to run this loop unless this condition is satisfied. So for the head, this condition will not be satisfied in this example. And suppose if we had only one element, then this would be sufficient for that only. So it will run only one. It will not run anytime. So our current will be pointing here only. So let's first see this example. Okay. So while this condition is true, what we'll do? We'll do current equals current arrow next and current dot next in Java. Okay, so after this code finishes, our current pointer will be pointing at the last element in our linked list. So in this case we don't need to change the head because head will be same. So adding an element in the middle or at the last doesn't make a difference to our head. Okay, now after this what we'll do, we will create a node. So let's create a node, we'll call it temp, and we will put the data pointed to us, and its next will be null obviously. Then what we need to do, we know that our current is now pointing at the last node, so our current has reached here. So now we simply need to make the currents next equal to this temp. Okay, so we'll first create node. So let's suppose list node or whatever they have initialized, list node pointer temp in C++ equals new list node with data. Okay, so we'll create a new node, then we'll do currents next equal to this new node temp. So now our linked list is linked, and that's it all. We don't need to do anything else. Okay, we don't need to return anything because the head will not change in this case. Or you can they can ask the head if they've given the condition that the linked list can be empty also. So if the linked list is empty, then we need to return our temp only. Okay, suppose if there is no elements in the linked list, so what we'll do, so we'll make a temp and we will simply return this temp as head. So now our temp will become head. unless if there is one element or one or more elements, we will simply add them at the end and our head will not change. Okay, so now let's move to the code. So there is a problem. Insert a note at the tail of a linked list on HackerRank. You can find this problems link on the description. So Java's code will be displayed on the left side, and I will be writing C++ code on the right hand side. Okay. Now let's see. Let's first make a temporary node. So we'll first create singly linked list node. Temp equals new singly linked list node, and we will add data to it. Now we'll check if head equals null. It's possible that we are given the null as the head of a linked list. So in this case, we will simply return the temp as our head because it has only one data. So temp can be head. So we return temp, and if it's not the case, we will create a singly linked list node and we will name it current, and it will be equal to head initially, and we will move it while current next is not equals to null. We'll keep on moving the current to current next. Okay, so current equals current next, and after this what we'll do current next equals temp. So now the node is added at the end of the list, and the head will not be changing in this case, so we'll simply return the original head. The head will only change when the head was given empty. In the rest of the cases, head will remain the same because you're adding the linked list node at the end. Okay, so now let's try to run it. So sample data are passing, and if we submit it, you'll see all the test cases are passing. So what will be the time complexity for this solution? So as we need to traverse the whole list, and even though we are adding a single element, the time complexity for this will be big of n. So if you watched the video till now, please make sure you like the video, this video with your friends. So thank you and see you in the next video.